Okay, guys, now let's look at question 6. Maria is saving money over the next year. She makes initial deposit into the saving account of 100. She puts in another 11 deposits, each one 10 more than the previous. Okay, so based on this description, let's create a list of the number. So based on the question initial, right? This is without making any deposit. Without that 11 deposit. So let's use a 0. So this is before this 11 deposit. So the term is 0. So we have 100. That's how much she start with, initial value. And first deposit, she put the extra $10. So the first deposit will be 110 into her bank account. So will be altogether will be $210, right? The second deposit, she adds $10 more than the previous amount. So will be another 10 adding to 110. So it will be 120, and the third one will be 130, and so on. So with this pattern, we can find out from the 11th month, after 11th deposit, she gonna have 210. Because you just keep adding 10. Right? So next one will be 140 and keep going. So on the 11th, after 11th deposit, it will be 210. It is arithmetic sequence because if you look at the numbers, each next term will be always extra 10, right? The common difference is 10. So D equal to 10. We need to find out N. Be careful. You have an 11 deposit, right? So starting from 1 to 11, there's an 11 number. However, we cannot forget that we have a 0 in front of 1. So we need to include this one. So instead of 11 deposit, we actually have a 12 turns, n equal to 12. We're finding the sum, okay? Finding the sum, use this notation starting with a 0, right? This is 0, and you end with 11. Okay, I know I wrote it in this way. However, even it start with a 0 and with the 11, there's a 12 turns. Okay, we're going to use the formula. This formula comes from the sum of arithmetic sequence, which is the first one plus the next one, and we multiply by n over 2. Okay. However, here, if you see, I actually start A0, which doesn't really matter. This just telling us this is the first term, but in our case, we have A0 as the first term. So our next term is named as A11, but that is the next term. We're adding the first term with the next term, and we divide the term number by 2. Okay, so we do have the first term, which is 100. We have a next one, which is the 210. Right? Let me also show how to get this 210. You have, this is A1, right? If you have A1 equal to 110, and your AN will be what? 110 plus, okay, 11, because we're starting with this one, right? That's why we have 11 minus 1 times the difference, which is 10. Okay, and then you have this is 10 times 10, so you'll also give you 210. So if you wonder where the next term come from, It comes from here. Okay, this corner. Okay. Now it's all about applying the formula. This is a formula for the sum of arithmetic sequence. You identify the first term and the last term, you add them. Be careful. Sometimes it could be tricky finding how many terms. So if you're not really sure, just list all of it, right? You'll start with the first, you have a 100, right? You start with a 100, that's initial amount. And then you have another 11 deposit. So altogether should be 12 deposit. Okay. Substitute the number here and here, and the answer should be 1,860. Okay, now let's look at question 7. Which of the following does not represent the sum 9 plus 11 plus 13 plus 15 plus 17? Okay, if you remember, we mentioned, right, your formula can be different. You have actually infinity formula based on what? Based on your starting value. Okay, it could be changed. Doesn't mean that you only have one answer. You actually have many formula you can use to represent this expression. So the better way here is you are going to testify each one and then see if it works. What does that mean? So you look at your first term, which is 9, right? So your first term is 9. Let me just write first term. Your first term is 9. Now you look at this equation, you look at this one, you want to see if it works here. So you start with n equal to 2. And this is your formula. So you start with n equal to 2, you need to substitute n with a 2, right? And that gives you 2 times 2 plus 5. And that is 9. So that means this one worked. Well, if you want to play this safe, well, try maybe last one that is telling you that is f of 6. Right? Once again, this is your equation. This is your formula. 2 times 6. 2 times 6 plus 5, and it does give you 17. So this one definitely worked. Okay? Do the same thing for the other 3. Okay, do the same thing. Let me show you. Okay, so if you look at my notes here, I did the same thing for the choice 2. I figured out my first term using n equal to 4 into this equation, the formula 2 times 4 plus 1. It does give me 9, so that means it worked. So I try again, it also worked for my last term. My last term is when n equal to 8. The choice 3 also worked, so that means the only one that doesn't work should be 4. Okay. Okay, now let's look at question 8. A sequence is defined by the rule an equal to am minus 1 over 2 plus n. Given a1 equal to 20, let's find the value of the sum of ai starting with 1 up to 3. So once again, guys, you need to understand what is an and what is an minus 1. Basically, if you have an here, your previous term going to be an minus 1. So you need to understand that. That's a previous term. I don't care what the an is. If it's second term, that means your previous term going to be first term. If an is the third term, your previous term going to be in the second term. Okay? So we need to find out 8 or 2, because if you look at the question, it's asking you to find a1, I equal to 1, right? Starting with a 1, and you also need to find a2 at all the way up to a3. This is what this notation tells us. Find the sum, starting with the a1 and with the a3, okay? So we need to find a2. A1 is given. We can use this formula. This formula is telling us A2 equal to previous term, okay? Previous term, which is A1. A1 divided by 2 plus n. In this case, n equal to 2. Look at the blue one, n equal to 2, right? And you substitute n with the 2, and you substitute A1 with the 20, because A1 is 20. And you do the computation, 10 divided by 2, and then add it to 2, that gives you 12. After you find out A2, you need to use it to find A3. Once again, this formula tells us you need to use the previous term divided by 2n plus n. Now, we move on to A3. That means n become 3 now. A3 equal to previous term A2 divided by 2 plus n. A2, we got it from the previous step, which is 12. 12 divided by 2 plus 3. Once again, this time n equal to 3. See, n is changing all the time, right? And that gives us 9. Okay, and then we're going to add all those 3 terms. This is what the question is asking for, and your answer is 41. All right, now let's look at question 9. The first 3 terms of geometry sequence that tell us this geometry sequence, so we should have the same ratio, times the same number to get the next one, okay? We're gonna find non-recursive formula. That means I want my A1 shown in my formula. I want my A1 to be shown. That basically, that's this word means. So that's totally fine, right? Because we know in order to find a certain term for the geometry sequence, this is the formula. An equal to A1, always start with the A1, you multiply by the ratio to n minus 1. So the key components we need to find is R, and then also we need to find A1, that is actually given, right? A1 is 16. How do we know what the R is? Remember, R, that means the ratio. So you take the second term. Remember, you take the second term and you divide it by the first term. Second term divided by the first term, or the third term divided by the second term. Either way, it will give you the same answer, okay? But I take the first two, okay? 20, A2, 20 divided by 16. I simplified it and it give me 5, 4. It's okay to leave it as a fraction, but if you do not like a fraction, you can also write it as decimal. Who cares, right? So that is 1.25. That's totally fine. As soon as this is convertible. Sometimes if you have a 5/3, then just leave it as a fraction because you're gonna have a repeating decimal. Okay, now that's enough. When you have everything, you're going to assemble them together. A1, you replace it with the 16. Or you replace it with a 5/4 and then just leave n alone, because that is what the formula is supposed to be. You do have the variable input and output. That means whenever you give me n, I will give you am, okay? All right, so that is for question 9. I think we can go one more. All right, so this one, actually, it's a little bit tricky. It may take a little bit to find out, but let's just play with it. So you need to find the summation notation, all right? This is neither arithmetic nor geometry, okay? Not all the sequence is either one or the other. It could be something different. But we can also look at the pattern. So we want to write a summation notation. Keep it in mind, you always have a starting value. You always have I up to n, right? The number there, and you also need the formula, okay? There's a 3 component you need to find. So I look at my number, I see certain pattern. Once again, it's also a little bit tricky for me. Excuse me. It's not easy to find it, but you're gonna play with it. So notice the numerator is increased by 1, so 10, 11, 12, and 13. And also notice, so for 7, I can use 17 minus 10. For 6, I have a 17 minus 11. So what doesn't change is, look, 10 and 10 here well, 12 and 12 here, 13 and 13 here.